Hello, welcome to the Exhausted Programmer. My name is Alexander, and today we'll be talking about binary. What is binary? Binary is a numeral system. We have our own way of counting and doing math, and all the math that we do can also be done in binary. It's just a different way of expressing values. A good way of understanding it is first to better understand our own counting system. In our own counting system, we start with 1, and then increase it to 2, and then up to 9. Once we have 9, we go to 10, but let's think about what we're really doing. We're bringing back the 1 just in a new place. I like to think of it like apples. You start with 1 apple, and then you add, and you keep going until you get to 9, and then once you add 1 more, you put it in a box, and you count the number of boxes you have, and then you continue on. And very quickly we can see how many apples we have by counting all the boxes, which each represent 10, and every apple that's not in a box at that point. We can continue this and make boxes of boxes, and that's what the next number is for. And each time we add a new digit to represent 10 of the previous digit. Similarly, binary works the same way, but in this case, you only get 1 apple before you put it in a box. That is to say, once you get 2, you have a box, you move it over, and you keep on going. If we understand this, then we can quickly start to understand small values in binary. We can see that a 1 is 1, 10 is our 2, 1, 0, 0, 0 would be our 8. Similarly, we could use a number other than 2 or our 10. We could use 16, and that's where hexadecimal comes in. And anytime you see hexadecimal values, it's just a way of writing binary, but quicker. I shouldn't say every time you see it, but often it is. And that has to do with the fact of converting from binary to hexadecimal is a lot easier than binary to our normal numbering system, due to the fact that 16 is a power of 2. Now, binary is a math system, but we do have certain rules in our math system, or certain patterns that we've noticed that makes doing certain things easier that doesn't work in binary. Such as, if you add up all the digits in our system, and the value is a number that is divisible by 3, then the larger value is divisible by 3. It just happens to be a quirk in the way we do things. This does not work in binary. What does work in binary, if you ever have to divide something in half, all you have to do is shift the numbers over by 1, and similarly shift it the other way in order to multiply by 2. Just as we can tell if a number is divisible by 10, if it starts with a 0 or has a 0 in the far right, I should say, binary works the same way but with value of 2. That is to say, if there's a 0 on the smallest digit, then the number as a whole is divisible by 2. And like 100 in hours, we can do the same thing with 4. If the 2 smallest digits are zeros, then the number itself is divisible by 4. So some things are easier, some things are harder, but everything's done by a computer anyway, so what do we care in the long run? A question that might be asked is, why do we use binary? I think the simplest answer to give is just that electricity can be there or not down at the lowest parts of the computer, that is on the actual copper wiring. And if it's there, we can read that as a 1. If it's not, a 0. There are other added benefits. Even before electricity was introduced, binary systems were used as a way of coding data into things. I say coding, but we're talking about looms here. So predates computers, predates coding, or at least what we think of as programming. Another question that might be asked is, how do we use binary to represent things on the computer? Numbers seem kind of obvious, at least whole numbers. But with colors and with characters like letters, all you need to do is create a table, and for the first value in that table, give it the value 1, and for the next value, give it the value 2, and so on. As for floats or fractions, if you've heard the term float before, and if not, fractions or doubles, instead of counting whole numbers, we can count fractions. So if we wanted to track halves of stuff, all we have to do is count how many halves we have. And at the end, we could get a number that has a whole number and a decimal, and then followed by something after the decimal. If we need to be more precise, we just count smaller fractions. Binary can be something that is off-putting for people who don't know what's going on, but as you can see, it's a very simple thing to use, a very simple thing to understand. It predates computers, and if you want to look into more about ways of using binary, Boolean values is fairly common, and that again was something that predates computers as well. All we did with computers is use existing ideas and systems in order to implement the simplest machine we could back when computers were a lot slower. If you have any questions about technical topics that you would like a non-technical description explanation, please feel free to ask questions in the comments. Thanks for watching.